Hello everyone, welcome to this deep dive episode of Physiology Unlocked. Today we're going to unpack one of the most fascinating and practical topics in exercise science: the different type of muscle fibers that make up every movement you do, their unique characteristics, and exactly how to train each type for maximum growth. Whether you're chasing a bigger lift or better endurance, or simply want to understand why your body responds the way it does to training, stick with me. This one is packed with science, real world examples, and actionable takeaways you can use straight away. So, let's dive in. First, a quick foundation: your skeletal muscles, the ones that move your bones, are made up of thousands of individual muscle fibers, each one essentially a long cylindrical cell packed with contractile proteins called actin and myosin. These fibers don't all work the same way. They're specialized. And that specialization explains everything from why some people are natural marathon runners to why others explode in the gym. Scientifically, we classify human skeletal muscle fibers into three main types based on the myosin heavy chain isoforms, contraction speed, metabolic pathway, and fatigue resistance. We call them type 1, type 2a, and type 2x. Let's meet them one by one, starting with the endurance champions. Type 1 fibers: a slow twitch, a slow oxidative, often called red fibers. They contract slowly, reaching peak tension in around 100 milliseconds, 1/10 of a second. They produce relatively low force, but they are incredibly fatigue resistant. And why? They rely on aerobic metabolism, oxidative phosphorylation, which uses oxygen and fats or carbohydrates to generate ATP efficiently and in huge quantities. They're packed with mitochondria, the powerhouses of the cell, plus the high level of myoglobin, which stores oxygen and gives them that rich red color, and a dense capillary network for constant fuel delivery. And real world examples: think about standing in a queue for half an hour or hiking all day. Your postural muscle, like the soleus in your calf, are dominated by type 1 fibers, often 70 to 90% in that muscle alone. That's why you don't collapse from fatigue just holding yourself upright. In elite endurance athletes such as long distance runners, cyclists, key muscles can show 80 to 90% type 1 fibers, allowing them to sustain submaximal efforts for hours without lactic acid buildup. Numerically, type 1 fibers have the highest oxidative enzyme activity and mitochondrial density, but the lowest peak force output, roughly half that of fast twitch fibers. They recruited fast for any movements, thanks to Henman's size principle, which we'll come back to. And now let's move to the middle chart: type 2 fibers, fast twitch, oxidative glycolytic, sometimes called intermediate or pink fibers. These contract faster, roughly twice the speed of type 1, generating moderate to high force. They have a nice balance decent oxidative capacity with plenty of mitochondria and capillaries, but they can also switch to anaerobic glycolysis when needed. Are they fatigue resistance better than pure fast fibers that I explain later, but not as bulletproof as type 1? They're versatile, perfect for activities like fast walking, moderate pace cycling, or team sports with repeated sprints. In the average person, type 2 make up a significant chunk of mixed muscle like the vastus lateralis in your quadriceps, often 30 to 40%. Endurance athletes still have a good proportion, while power athletes use them as the workhorse. And finally, the sprinter's favorite, type 2X fibers, fast twitch, glycolytic, the classic white fibers. These are the pure power machines. They contract the fastest, reaching peak tension in under 50 milliseconds. And they produce the highest force, up to 3 times more than type 1. But they pay a price: very low oxidative capacity, few mitochondria, reliance on stored glycogen, and anaerobic glycolysis, which means they fatigue rapidly, often within seconds to minutes. You'll find them dominant in explosive movements, a maximal sprint, a heavy deadlift, or jumping to catch a ball. In untrained people, they might be only 10 to 20% of a muscle like the vastus lateralis, but elite sprinters and weightlifters can have 40 to 60% fast twitch fibers overall, with a higher proportion of 2X fibers. An important note: in human, we rarely see pure 2B fibers like in rodents. It's mostly 2X, and many fibers are actually hybrid, co-expressing more than one myosin type, such as 1, 2A, or 2A, 2X. These hybrids can make up 20 to 30% of a muscle in some cases, giving them more flexibility. So now you know the players. How does your nervous system decide which one to use? This is where Henman's size principle comes in. A beautifully elegant piece of biology. Motor units. A motor neuron plus all the fibers it controls are recruited in order of size. A small, slow, fatigue-resistant type 1 units fire first for low intensity tasks. As demand ramps up, heavier weights, faster movement, or longer duration, larger type 2A units join. And finally, high threshold type 2X units for true maximal effort. That's why a light jog mostly uses type 1, but a heavier squat to failure will eventually recruit everything, including those powerful 2X fibers. Now, the million-pound question: how do we train these different fiber types for optimized growth? Because hypertrophy, the increase in cross-sectional area of the fiber, is what most of us want, whether for strength, aesthetic, or performance. First, the good news: all three fibers types can hypertrophy within the right stimulus. Studies consistently show resistance training increases fiber size by 20 to 40% over 8 to 12 weeks in trained individuals. With type 2 fibers, often showing the largest relative gains because they have greater potential for protein synthesis. But the stimulus matters. For type 1 fiber hypertrophy, the endurance specialists, these respond beautifully to higher repetition training taking close to failure or to low load work with blood flow restriction, often called BFR training. And why? Because they're recruited early but need high volume and metabolic stress to grow. Research using low load protocols, 30 to 50% of 1 rep max performed to failure, has shown that type 1 fiber cross sectional area increases of 15 to 20%, sometimes matching or even exceeding type 2 gains in those conditions. Let's have practical example. 3 to 4 sets of 12 to 20 reps on leg extensions or calf raises, with short rests or BFR reps on 20 to 30% load for 30 to 50 reps. Think bodyweight circuits or high rep finishes. Endurance athletes can add this without losing their aerobic pace. For type 2, especially type 2X, the power fibers, these are high thresholds, so they need heavy mechanical tension. Classic high load resistant training, 70 to 85% of 1 rep max, 6 to 12 reps, 3 to 5 sets, is king. This preferentially recruits and stresses the fast fibers, leading to greater hypertrophy here. Meta-analysis show high load training produces roughly 20 to 25% more type 2 fiber growth compared with low load in many studies. Think of compound lifts, squats, deadlifts, bench presses performed explosively on concentric phase but controlled and slow on eccentric, excuse me. Rest 2 to 3 minutes between sets to allow full recovery and repeated high force output. A hybrid approach for most people. Since muscles are mixed and most of us want balanced development, the smartest program combine both of high load and high volume. For example, a session might start with heavy compounds for type 2, then finish with higher reps, accessory for type 1. And there is a question about fiber type shifts. Resistance training and power training reliably shift 2x fiber toward more oxidative 2A phenotype, often reducing pure 2x by 10 to 15% while boosting 2A by 15 to 25% in 6 to 12 weeks. This makes your fast fibers more fatigue resistant without losing power, a win for most athletes. Endurance training does the opposite, nudging toward more type 1, 2A hybrids. But full conversion from slow to fast or vice versa is limited in human. Genetics set the baseline. Training fine-tunes. A couple of evidence-backed tips before we wrap. 1. Progressive overload is non-negotiable. Whether heavy or light, you must keep challenging the fibers beyond what they've used to. 2. Eccentric phases. Slowing the lowering phase to 3 to 4 seconds can enhance hypertrophy across types, especially type 2, because it creates greater mechanical stress. And 3, nutrition matters. Adequate protein, 1.6 to 2.2 grams per kilogram of body weight daily, plus total calories in a slight surplus, fuel the repair and growth all fibers. And 4, recovery, sleep, stress management, and deload weeks every 6 to 8 weeks prevent overtraining, which can blunt hypertrophy in both fiber types. And finally, real-world athlete examples to tie together. A marathon runner with 90% type 1 in the soleus thrives on high volume running, but can add targeted low load or BFR work in the gym to grow those slow fibers further and improve economy. A sprinter with 60% fast-twitch fibers dominates the track with heavier squats and plyometric, yet benefit from some higher reps work to shift 2x toward 2a, gaining durability without losing explosiveness. And bodybuilders, we often show impressive hypertrophy in both because our programs hit every recruitment threshold. So, to summarize the key takeaways, type 1 fibers, fatigue resistant, aerobic, ideal for posture and endurance. Train them with higher reps or BFR for growth. Type 2A, versatile intermediates, balanced training, hit them well. And type 2X, explosive powerhouses, heavy loads, and low reps are their language. Train according to your goals, but remember, a well-rounded program that progressively overloads all fiber types will give most people the best results. There, you have it. The complete science of muscle fibers and how to train them with optimized growth. If you enjoyed this deep dive, please hit the like button, subscribe so you never miss an episode, and drop your comment below. I read every comment and I answer as many as I can. Thank you so much for watching. Train smart, lift with purpose, and I'll see you in the next episode. Take care.